All right. So thanks for coming. Can everybody hear me? You good? All right. So patching Windows Executables with the Backdoor Factory. It's a script that I wrote, and then it works for kind of a year. It's just automates a bunch of things, and I hope that you guys like it. And here we go. So there's some other potential titles that I was thinking about for this talk that just didn't make the cut because they weren't serious enough. So down to APT, so you know me. Last week, until we fall in code kit again. Why I cyber and you can cyber too. Why ET met EMET. Whole story. If I get way to the top one bucket at a time. It's going to be Dave Relics, Dave Kennedy's biography. How I owned your mother. So about me, I do not work for the village people. That was actually a pin testing uniform. I'm a U.S. Marine. I got out before 9/11. I do IT stuff now. I'm a reverse engineer, pen tester. I dabble in these languages. I have some certifications. If you want to look on LinkedIn, go ahead. And I work at Leviathan Security. And now, while Googling about myself, just to see what was out there, I came across Urban Dictionary. I said that I'm a very sexy beast. Enough said. All right, so we're going to go over the history of patching. How I learned. We're going to go over my code. We're going to do some crappy demos. Thank you, Mac. Steve. And then we're going to talk about mitigations and some things that we can do going forward. So this is the Wikipedia definition of patching. It's long-winded. I'll give you a second. Okay, that's enough. This is my definition of patching. Add or take away content or functionality to a compiled binary. That's it. Good or bad, that's what it is. So why us as security pros should do patching? Red teaming, persistence in plain sight, pen testing, social engineering, salt all the parking lots, literally salt the parking lots, all over the place. They walk in the parking lot with USB table. Research, it's kind of funny, and malware code analysis. This is what we're talking about today. Even Warren Buffett has some stuff to say about patching. And maybe that's why he doesn't invest in technology companies. Because if he did this with operating systems, we wouldn't use it again. So the Microsoft method. There's a Microsoft install patch file. It does some things, updates install database and whatnot. And then it applies the patch from the Kevin file, stream file. Blah, blah, blah. It's not, it just basically replaces old executables with new executables, DLLs, and registry entries. It's not the patching we're talking about today. How key genders crackers do it. Basically, what they do is they find a section of code that they need to defeat so they can have the program do something that it wasn't supposed to do, such as be for free. So how does Metasploit patch? When it comes to Windows binaries, there's two things. It comes from MSF Venom. This is kind of what we're going to be talking about today. This is how Microsoft does it with MSF Venom. It's called the template method, and that's the text file. And what it does is overwrites entry instructions. We'll go into that. The other way is the keep method, -k. And that tries to keep the functionality of the executable as it were, so the user doesn't know anything. It does it pretty well. We're going to talk about some things. So this is the first part where, so this is PSExec before MSF Venom gets to it. This is after. It's been munged. There's no way that this executable is going to run normally again. It's just going to give a shell or a name to an attacker. The user is not going to be happy. It's basically a win-lose because the user is not going to use it over and over again. The MSF cred keep method, as I call it, or the stager method. When you look at this in immunity, you get this error message. And basically what it means is that we're starting in an unnamed section. And immunity is so true because that's where it's starting. And then below is the original. So the keep method. There are two separate stubs. The first stub is pretty new. The second is something that we already know about. if you use MSF payload and you get payloads out of that, that's what we usually see. The first part is pretty new. Well, it's not new, it's been around a while, but the only way you're going to get it is through MSF demo. So there it is. Can you tell where it is? Anyone? It's right there, yeah. Right there. So this is the first part. And what this first part does is it takes the second part and throws it into a separate thread. And so it copies all that payload, which is reverse TCP, I believe, and it throws it into a separate thread, and then it launches that and it jumps back to normal execution. So there's some pros and cons of this. For the user, it's a win-win. You get a shell, the user gets a program that works. But unfortunately, this method is easy for an AD to catch because it's an unnamed section that you jump into immediately that has no business to do with execution. And also the binary size is increased if you're doing any analysis for that. Of course, the hash has changed, but yeah. So as far as this is only for 32-bit. MSF Venom does not support 64-bit patching of Windows executables. It will create an executable that just gives you a shell, but it will not patch the x64 executable. So I submitted a bug post, and they created a feature request. Because I can't see so it's not easy to go from 32-bit to 64-bit. It's not a one-to-one port shell. It actually takes some thought. So we're going to go with DerbyCon. The portable executable format has been around for a while, 20 years. It's backwards compatible. So Windows 8 can read 16-bit executable. You go, no, I'm not going to run it. So it's been around. There's a lot of research out there that you can read on it, so it might be going into too much depth. The Kah format. This is really what's important to us. The tool that I'm releasing, or have released, it reads both the PD and the Kah, and helps us figure out what we need to use the executable to inject our code into. So that's the end of that. So how did I learn how to backdoor Windows executables? I took CTP. It was manual labor. It took hours the first time around, but now I can do it about 10 to 15 minutes. It takes the course, I believe, about 2 years ago. And thank you, Mike. All right. So, but the course was missing some important concepts, like working with C64-bit, doing decay jumping, working with the import table, working with stage tables. We didn't go into any of this. So, in the CTP, we learned how to append and do code code. Similar to the keep method that we discussed. And we looked at XOR encoding, but really XOR encoding these days, there's a class I think was written in 2008, 2009. XOR encoding really doesn't do anything for AV as far as bypass, most AV especially. So this is the CTP method. So you have your code set up. We're going to have an activity section for code case and shortcode. Yes, code case. What is that? So code case is an area of executable that contains null bytes. That means nothing. So that's code case. So how are they created? Because people ask me, I never really thought about it. So people are like, how are they created? And I don't know. So I went on a quest. That's me. This is when it gets weird. My wife doesn't like it. So it started out that a unicorn was going to everything. So I went to DerbyCon. What's better than unicorn DerbyCon? Yeah. That's amazing. So you gotta have citations. You gotta be rich to the point. And so they. But they're very nice. Cordial. But they're also trolls. And then she disappeared. So alright. Let's do some research. I tested the following 32-bit compilers against this code, which is free if you want to use it. No licensing. So this is our first demo. If you want to grab the code, it's up on GitHub right now. This is like a classroom, so if you got your computer up, go ahead and grab it. So this is the first place where the demo got forgiven. All right. So who I have in the directory here. All right, so we have Chrome. Magically, we have Chrome in my directory. So you have a file, Chrome, and then you use the C flag. That's for finding caves. Now the default is 308 bytes. Nice banner. And then hiding. You turn on Okay, so we found 17 caves, 308 bytes or more. That's, a reverse TCP shell is about like 314, something like that. So let's look at let's change the length. Let's do 100. 108. Let's go down 50. 708 code cases. So if you can get your shellcode or chunk up your shellcode in different sizes and pop it into these code cases, you have a lot of choices. And AV is not going to be happy. Any questions on the demo? All right, appreciate it. So, for that one small piece of complicated code, these are the results. This is the compiler link from Microsoft at 7, G++ at 4, UGW at 3, and LCC moving to Hyatt 2. And just for a hello world. So, I admit that. So, in the code, I have this int array 600 bytes. 0. You'll notice that there was no code caves, or at least you didn't notice, but I checked it out. There are no code caves of 600 bytes in size. So, what does that tell you? Something to do with compilers. I agree that more research should be done in this area. I don't write them. What do I want to? So I was doing this manually, and I was like, all right, let's try to do something here. How about some automation? How about we take known shellcode and look at it and see where we can split it up into smaller sections. Let's use multiple code cases. Let's not do things in order. Have a user be able to take a bin file of raw shellcode and inject it into the executable, and combine the heap method, and that's called heap method, and use it as a way to use stagers. Because if you're going to use stagers, you have to have a way of returning back to execution. Not if you're going to use stagers, but any shell that we put into a executable, you have to be able to return to execution one way so that the program runs one way. And if you don't do that, the user's going to know something's up. So with stagers, you have to create a separate thread for everything to run. So the solution to that for Backdoor. I released the X32 version in March. It only supports single page jumping, no 32-bit stager support. So it's a single script, it's under 3,000 lines. Not much double spacing, it's pretty dense. So I support X32-bit stagers. I have a reverse TCP shell that I put in for X64. So I can do something that another support currently doesn't do. Of course, they hear that, they will be done soon. It does code cave injection, single and multiple, so it can jump around. So you can provide your own shellcode. And I do some randomization. If you guys didn't know, there's different types of mounts besides 90. There's 66, 90, 65, 90, 34, 90. So there's 2 byte mounts. And then I also have an injector module, which goes out and hunts for executables. You can drop this on a box, a Windows box, give it some command line arguments, and it will hunt for and inject into these original executables and kind of just inject code into them. It's kind of fun. So how does it work? So I enumerated the DerbyCon header format. That's why I covered this side. Determines the binary support, locates code caves, and corresponds to the size of the shellcode that you're using. And then it patches the executable and attempts to return normal execution. So it tries to return all the registers and flags to normal, to what it would have been if you just started without any modifications. So it's a very primitive disassembler. It only does enough disassembly to find, really, to do whatever it needs to do. That's the easiest way to say it. So I reworked the X32 standard shell code from MSF Gunning to work in this. So X64 is in the works, and also reworked a couple of the useful and metasploit payload options so that we can split into smaller chunks, and I'll see it in a demo. So this is some shell code from metasploit, and you can tell where the jumps are by the blue and red arrows. If you were to split up the shell code there, it would make your life very complicated because you have to track every jump and fall. And that's not fun. So I start there. So this is the original way that the backdoor factory works. Pretty simple. Jump to code A, execute code, jump back. Easy. So now you can do this. And now you can do this. All right, so time for some demos. All right, so the first demo is support check. So let's say I take this exactly. We type X. So cases I can support. So you don't have to waste your time figuring out if your executable is supported, if it's not supported. So that's the support check demo. Now we're going to go through and backdoor some Win3264-bit binaries. I'm going to show you some of the features of the backdoor factory. We're going to start out with pin and code data, and then we're going to do some single code data jumping and some data jumping.
Question.
Yes. So ASLR, that's a good question because I have to track ASLR. And so in Win32, the way I do it is simple math. Because I know where I'm supposed to be starting. I know where the executable is supposed to start. And so I jump, I do my shellcode stuff, and I work through the shellcode. And then once I get to where I need to resume execution, I kind of know where I'm supposed to be. So if I'm within 500 bytes of where I'm supposed to be, I'll say, okay, I'm not an ASLR. But if I'm more than 500 bytes, I'm like, okay, I'm an ASLR. And then I do some not very complicated math to figure out where I am. Now, the reason it's easy to do it in a binary is because you know where you're starting. Where you're supposed to start. Now, it's more difficult when you go into that's a good question. So, all right, let's append a code. So the first thing we're going to do is we're going to pick shell code. You can type whatever you want, but you can type. I still need a shell. So let's do reverse TCP shell. Reverse shell TCP. All right, we're going to get the port 8080. I'm going to make sure. All right, so that's the job I have waiting. Post and 10. Hopefully this works. And stuff. So I thought about putting some sleep cycles in there so it's more exciting. But it's fast. So that's pending code. Pretty easy. Now let's do code cake jump. Well, let's do a single jump. So a single jump, you just don't put any arguments, and it'll give you the sections that are ready. So let's pick section. By the way, what they do, what I do is we create, if you know what a directory is, a directory called Backdoor, and just execute in there. that's single page jumping. Now, let's do multiple page jumping. So you'll see that we have more code tags to pick from. So let's pick number 4, and we're going to jump across sections. And for those of you that know how Windows executables are loaded in the memory, you know that's kind of weird because what's on disk, as far as the size of the section, is not what ends up in memory. So I have to figure out what it's doing, what has to end up in memory. Because what happens is if you have a section of 200 bytes, it's going to end up with 1,000 bytes in memory because it just rounds up to the next even 1,000. So I have to figure that out. So we're going to do section 5 and section. Let's try 2. Because they don't believe that it's actually working shortly. The reason you're getting more is I use a stager as the multi-handler. Doesn't matter. You can tell that it's actually good. All right. Now, so we covered bend and jump. Let's do a different payload. Let's use reverse stager TCP. Reverse TCP stager. Now, there's less code here, so I can jump back and look at singles, like just a single K. And you can tell right here that there are no Ks available. If I didn't simply show it up, it would be nothing. So by going through and finding where I can simply show it up, sure, I have more Ks. So I can just go, also I can type a pin here and go right to a pin, well, just a pin on the end. So if I type jump it in, I go right back and jump. Well, let's say I pick section 35. Section 35 again by mistake. And so it's not going to work, but if I type jump, it'll start over. So let's do 7, we'll pick 9, and then 22 again.
So that we've been connecting to page and organization.
Yep. That's just correct. So if I exit out from here, you'll notice that the session is dead. So if you're doing this, you may want to migrate as soon as possible. But that's only with the stated data. Some of them. All right. Let's see what the next one is. So it's just pull it. All right, so we're going to do section 14. So, all right. So let's do section 14, section 26. and then 18. So any questions on that? Anything? Yeah.
So why would you make it a choice for the user to choose which cave cookie? Why not just randomly choose? Or is any better than any other?
So that's a good question because some caves will not work.
Okay.
Yeah. If a cave is named none, it has no section whatsoever, because I wouldn't use that for a good cave because you don't know exactly where it's going to end up in the movie.
Okay. So is that something you could automatically do, or
I haven't figured out a way to do it.
okay, just something you just have to know and look for.
It's a feature request. No, so like there are caves. So you want to test your executables out before you
Sure.
play the ones. Yeah. But there are caves that will break execution. I don't know why. I have no idea why. It's just maybe the voters needs zeros. Maybe the compiler needs. I don't know. Not the compiler, but the execution needs. So all right. Okay, so mass backdooring or injection. That's what I'm going to call it. That's the next good one. So I'm gonna append a code case to every system kernel tool. It's in the test array. So let's do /D's for that, and then so it's going to ask me if you really want to do this. That's 73 executables. Let's do the site. Runs faster when we're not having to be on the
How does AP work?
We're going to go into that. It's not fun. So you'll notice that okay, for system kernels, there's 64-bit and 32-bit binaries. Okay, so this reads the PE header, figures out which it is, and then applies to the shell code. If you say reverse TCP shell, reverse shell TCP, and it says, all right, I have one for 32-bit, 64-bit. When it's 64-bit, it'll just use that equivalent in 64-bit. So you don't have to sit there and say, what is this? It just will give you your options for what shellcode is available during the gift. So that's kind of fun. So if you open the, we'll just do this real quick. So you'll see they're all right here, ready to put on some NFS share or some share on the network for admins to use. That would be so yeah. So prototyping shellcode. This is actually a video, so let's go ahead and jump that. So by having the shellcode readily available in the tool, you can make changes to it pretty quickly to see if you can bypass AV. You guys see this? All right. So I'm taking backdooring with the shellcode that's in there. Projecting shellcode into this is actually this is Windows 8.1 with Windows Defender of course. So now I'm going to go in and I'm just I'm going to copy over and create a new like module of shell code, the module of payload. I'm going to take out what I feel is bad and then recompile it or redirect it and then put it back over. So that makes sure. That means there's something in the bytes that the segment is up. So I'm going to put a knob in front of it, looks like a push VAF section. And I have another knob in front of another push VAF. And then for this, I added, actually for that, I added 6690, that's one of the 2 byte knobs. And copy back over. Gonna run it and see if it works. So 4 bytes to bypass Microsoft security essentials. And it wasn't running as admin, that's why it didn't install the service. Any questions on that?
I have a question or a comment. We were just talking up here when you were mentioning about certificates not working. Do you think that could be because they're initialized to structs or any uninitialized variables within the program and it's actually breaking execution?
That could be it. Yeah. Yeah. Just haven't looked into it. It's just easier for me to just pay another pay. Yeah. So I don't think this counts as well down, right? Bypassing Microsoft security essentials. But for those I've written the last one. All right, so this is the next demo. It's the injector model. So, go ahead and get that going. All right, everybody see that? All right. So, see. Java right there, it's not Java, it's Backdoor factory. I don't know, maybe we like Java. There's one more dangerous, I don't know. So I'm going to execute it using the I flag and reverse TCP. I'm using also the A and D. The D flag means delete the original file. So it's going to inject code and delete the original file that was there. So cleaning this up is going to be a mess. I wouldn't do this on a pen test until you have to clean things up. So it's going through the entire operating system trying to find where the executables are, and we're targeting VM tools because that is the system. TeamViewer, Chrome, Process Exec, the Process Explorer, Procmon, is exec, and TCP. We can speed this up. This does take a little while. So I started TCP view. Because one of the things that Injector will do, if you write, everything's in a Python dictionary. If you write the dictionary properly, you can restart the executable or the service back after you inject it. So that if the user's not there and they walk away, you can make it look like nothing changed. Let me speed this up. All right, so it's injecting or hitting the good cake from. So now it's doing VM tools. It's killing the service. Stop VM tools. And restart this. Trying to restart it. And you'll see the shell pop up once it's been restarted. There you go. So now it's going for PS exec. Process explorer. Okay, you can see I went into VM tools below and did one line tests now. So now it's killing TCP view. Things are okay. Restarting it. Please shell. Restart. So now it's going to proc mount. Let's speed this up. Now it's going for T here. And it's done. Is that cool? You guys like that? Alright. Alright, so I don't have much time, so I'm going to keep going. Alright, so the provider and showcode model. Let's go ahead and do that. So the provider and showcode, you just pick an executor. Let's do showcode is, I don't remember. User supply showcode. Figure out and remember that. And then U is for the user supply showcode. And these are the showcodes that I created. Add user and command.exe because everyone hates pop. Or excuse me, calc.exe because calc is dangerous. So let's do calc.n. And let's do just one single page. You can see there's not much, so let's do a jump. So I got a little bit better selection, so let's do text, data, and then another data section. Now I got one. There you go. So now you can get into other machines and do your math. Yes, it's a feature. So let's add a user. So this would be hilarious to add user, especially if they figured out that something's on the box and so they remove the user. But then they run putty, you go to another box, and they just added another user. So let's jump. Alright. 4, 9, 10, 11. Our really good thing. And just so you guys can see. Whoa, doesn't work. Yeah. Oh, we run it as admin. There you go. All right. So attack scenarios. So assaulting parking lots with USBs. Yes, we do that. Posting rogue USBs or executables on a share on good attack system services such as VM tools, as you saw. So every time the machine restarts, we're going to get system shell. Also, the Linux set UID attack the Windows. You guys know what that is? It's the equivalent. So let's say you have TCP view on a normal user's desktop, and they need to run it. So you have to run that, you have to run it as admin. So what you do is, if they have TCP view or any other executable, they need to run as admin, and that's in a non-admin space. You can inject shellcode into that, and when they have to run it, you get an admin shell back. So mitigation, we go through a couple real fast because we're not on. So UPX encoding, I would use it because whenever you unpack in memory, you're probably going to unpack into, I think it's someone can verify, but I think you unpack to read, write, execute memory, or read, execute. It's not the same. It's just a non-packed execute. So mitigation, self-validation. So a TeamViewer actually has self-validation. You backdoor any executables with DLLs, because you need DLLs also. They have some kind of round robin going where they check each other. Kind of weird. I wasn't expecting that out of a company that doesn't do encryption 1.1. So I broke the rule of uploading executables to virus total. Because this is really matter. The baby is dead. In my mind. It's pretty much. Let's see. Okay, this is the SF keep method. The one that you use to keep execution normal. 35 out of 47. So this is the template method. And this is my method. 9 out of 47. When I release the slide, you go look at the hash. The interesting thing is that by the way, the VM I'm running is Mac. Mac doesn't catch it. Semantic doesn't catch it. The only ones that you've heard of that catch it are Squarespace. Who does?
It didn't catch me, guys.
It didn't catch it.
Movie cats.
Do we cats?
Yeah.
Well, yeah. But I mean, MSF showcode's been out there for how long now? Like 8 years, 8 years. Depending on what you're using. So this is 132 backdoor factory versus 164. So the zoom it, snapshot, 64-bit bid, but that's pretty much the same for 64-bit shell. Things by 80 or something. So keynote 4.0. So if you use position and shellcode from Metasploit, and the target binary is protected by CNET, and the caller protection is enabled, and the application is running 132, email will stop these binaries from running. However, if you're using Win64, ENET will not stop it. The caller protection will not catch this. From the ENET user guide, please note that the obligations are only available for pretty good processes and are confirmed. So, awesome. All right, so whitelisting. This is really the way you should go if you have a large enterprise. If you're not using whitelisting, you should probably use it. I'm not going to recommend any type of vendor, but it should work as long as you're actually whitelisting based on hash and not on name. On the right, everybody can do that. But it's not, whitelisting is not a unique solution because of all the PowerShell stuff that you can just inject in memory. So, enterprise mitigations. Don't let your end users download binaries. Verify your binaries before deploying. Verify your hashes. Do the normal stuff you would for your organization. And then, so the roadmap, we're gonna work on the x64 stub for stage payload. So we have the same for x64 as we do 32-bit. I want to go into L formats and Macho, or Macho, or whatever you pronounce it. And also, I want to patch the AIT, the import address table, and also load API pointers in so that you can have less shellcode so you don't have to look up your API pointers. And also, I want to get into random little hashing binaries turning down. So this is where we're at on the left. Any questions? Yes?
So does this currently work with DLLs?
It depends. Some DLLs it works, some it doesn't.
Does your dash S flag work with DLLs?
Dash S. No, but it does work, you'll recognize it, but whether or not it breaks anything is another story. It can patch it, it can find where it's supposed to go, but once you load it, it may not actually work. So, it just depends. I've had DLLs work. I actually found a DLL from Microsoft Office that if you open any Microsoft Office products, it will send a show. Awesome. Any other questions?
Yeah, documentation.
It's GitHub secret store. All right. Well, thank you very much for coming.